IOT transmitter, inductive output tube is what that stands for.
Okay.
They're quite efficient, much more efficient than the
old
solid state transmitter, which puts out half the power or less because of all the combining. That's why this is the main transmitter. The problem is, if it starts up from a cold start, it's 10 minutes to get a picture, where the solid state transmitter is more like 1-2 seconds.
So these are 2 tubes.
2 tubes. We'll open up and you can see them. They're IoTs.
Oh, okay.
It's like a tetrode input and a klystron output. It's it's a hybrid, but because of its design, it's quite efficient. You know, it's not 25%, it's more like 50 or 60. So it's one.
Yeah, there's two. I say there's 2 sets of transmission line there.
Yes. You know,
okay.
And they go up, you know, and then
they get combined someplace.
Yeah, I'll show you that.
Okay.
Okay. That first rack is basically a test rack. That's the exciter control rack. Amplifier 1, amplifier 2, V1 and V2, which is a valve.
Okay, V1 and then V2 valves.
Yeah, okay.
They're British.
Yeah, right.
Yeah.
Well, they're electronic valves. Okay, the signals come from the exciter split. It comes into this board, which basically does some AGC and linear ISO correction. It then goes to a small amplifier in the back there, which brings it up to about 5 or 10 watts. Starts out about 100 milliwatts. Behind this is they're actually 250 watt amplifiers. Those 2 amplifiers put out about 200 watts of linear power. Okay, and that then feeds to this guy.
That's much smaller than the old
oh yeah. Well, the tube
klystron, right?
Only about that big.
Yeah.
Basically, the top is the input cavity assembly, which is to the center. Then you have 2 output assemblies with a coupling and output coupling. And by adjusting the cavities, one at the low end, one at the high end, and playing with the coupling and the match, you can then get a nice 6 or 8 megahertz.
Wow.
As a 3D hybrid combiner, a balanced combiner will, when you use one amplifier, will equally divide the existing power, 50%, between the reject load and the antenna. So after it is combined, and this is a reject load, so any mismatch will keep some water in there.
Right.
It goes around this waveguide.
Okay.
Into this mask filter, M-A-S-K filter. When the one transmitter is in the antenna, the other transmitter is in the dummy load here.
Wow.
So right now we're on the main transmitter, which comes out and goes here, converts from waveguide to transmission line, and goes out to the tower.
What is that, 9-inch line?
8 3/8, I think it's. These cabinets here are what they call the line control cabinets. All the power switching on and off of the transmitter and the beam supplies is done through these cabinets from the main control panel. So when you push the on button, it closes a relay, which then has resistors in the beam supply. The beam supply starts to charge up the capacitor. A second later, a second relay comes and shorts out the low value resistors and puts full beam voltage on. This way you don't blow up the rectifiers. You put the power on, and those heavy capacitors trying to charge to 36,000 volts. They're remotely reset. You can reset them remotely by the remote control. Any function here can be reset by remote control.